Now let's talk about polarimetry. We'll be analyzing proline in this way. So we're going to have a solution of proline, our solvent, water in this case, and a polarimeter cell. Let's begin by looking at the polarimeter cell. The polarimeter cell is exactly 1 decimeter long and has black end caps and a stopper on top for gas applications. So we'll be leaving that stopper in place. The black end caps are threaded and can be removed so that liquids can be introduced to or poured out of the cell. When doing this, be careful because there are small circular windows that are trapped inside that can fall out from time to time. So let's replace that cap. Now, the polarimeter cell actually has a path through the center, and this is the path that the light will take when analyzing your sample. Next, let's load a blank into that polarimeter cell. We're going to begin by threading the black cap off, being careful not to lose the window inside, and then fill the polarimeter cell with water. It's easier to pour the majority of the liquid in that you'll need directly from your source. As you reach the top, you may want to use a pipette to try to avoid having any spills. Next, we'll replace that black cap. And we'll agitate the polarimeter just a bit to be sure that any air bubbles inside make their way up into the top, because we don't want any air bubbles in the cylindrical pathway where the light's moving. Now that we've got our sample cell loaded with the blank, let's zero the instrument. We'll open the front compartment to the instrument and then place the sample cell inside on the 2 rails designed to hold it within the beam of light. Next, we'll close the compartment door, and then we will zero the instrument. To do this, we use the keypad on the right, pressing the 0 button and then allowing the instrument to do its thing. It'll let us know when it's done. Once it's been zeroed, we want to remove our blank and load our sample instead. To do this, we open the sample compartment and remove the cell. Next, I'm going to unthread the black cap and pour the contents of the cell into a suitable waste container. Next, I'm going to load my sample into the cell. Now remember, it's easier sometimes to take a sample and pour it into the cell because it's a relatively large volume. But we don't want to have a spill, especially when we have a solution. So I'm going to stop just before I reach the top, and then I'm going to use a pipette to add the last few drops to be sure I have enough liquid inside to completely fill the cylindrical pathway where my light is going to be moving. Now that I have the cell completely filled, I'm going to replace the cap, threading it on securely, being sure that I don't lose the window inside. And then, again, I will agitate the cell just a little bit to be sure that any air bubbles trapped inside of that cylinder make their way up into the ground glass fitting. Next, I'm going to place that cell back on the compartment rails and close the compartment. Now I'm ready to collect my data. I'll go to the keypad and press Run. The instrument will run 5 different scans and then report the average of those 5 scans. So be sure that you wait until you see the scans complete. Our instrument is now conducting the first scan, now the second, and so on. When it reaches the final scan, you'll see a statistical standard deviation given at the bottom of the display. When you see that number appear, you know that the number above it, the alpha, is the average of the 5 scans. So our sample has a rotation of negative 0.327 degrees. That's the number that I'll be recording in my notebook. Now I'm ready to clean the cell and hand the instrument off to the next student.